In the vast expanse of the night sky, the moon has always been a silent observer, keeping its secrets close. But what if we told you that we've finally cracked some of its well-guarded enigmas? Welcome, fellow stargazers and lunar enthusiasts, to an exciting journey of discovery. We're about to embark on an exploration of the top 10 revelations from China's Chang'e 6 lunar mission. A mission that has given us fresh insights into the moon's enigmatic persona. From the astonishingly low water content in the lunar mantle to the compelling evidence supporting the giant impact theory and the tantalizing prospect of the moon as a potential resource, we've got it all covered. So, buckle up and join us as we unveil the secrets of our cosmic companion. These are discoveries that could change our understanding of the universe, and you don't want to miss a single one. So stay tuned till the end for all the exciting details. Have you ever looked up at the moon and wondered what secrets it holds? Well, you're not alone. The moon, our closest cosmic neighbor, has been a subject of fascination and exploration for centuries. And just when we think we've learned all there is to know, a new mission unveils fresh mysteries and insights that leave us awestruck. Today, we're going to talk about one such mission, China's Chang'e 6 lunar mission. This mission successfully collected nearly 2,000 grams of samples from the moon's far side, opening up new perspectives on lunar geology and deepening our understanding of this celestial body. It's a tale of cutting-edge technology, scientific curiosity, and the relentless pursuit of knowledge. So let's delve into the lunar mysteries uncovered by the Chang'e 6 mission. Starting at number 10, the Chang'e 6 mission was a successful sample return mission. Now let's unwrap the details of this remarkable accomplishment. We're talking about a mission that ventured to the far side of the moon, a place that has been always shrouded in mystery. The purpose? To collect samples, and oh boy did it deliver. Chang'e 6 managed to collect 1,935 grams of lunar samples. That's nearly 2 kilograms of pure, untouched lunar soil and rock. Imagine that. The samples collected are not just any samples. They are from the far side of the moon, a place that is so different from the side we see from our humble abode, Earth. This feat is not just a testament to the technological prowess of the mission, but it also opens up a whole new vista of opportunities in lunar research. With these samples, we can delve deeper into the mysteries of the moon, its origin, and its geological history. This monumental achievement sets the stage for our next insight. At number 9, the lunar samples showed lower water content in the lunar mantle. This intriguing revelation brings us one step closer to deciphering the enigmatic nature of our celestial companion. The Chang'e 6 mission's lunar samples from the far side of the moon revealed a stark difference in water content compared to samples from the near side. This disparity offers a tantalizing clue to the moon's geological history. While the presence of water on the moon is not a new discovery, the differentiated distribution in the mantle is. It not only affirms the moon's dynamic geological past, but also provides insights into the processes that have shaped its present state. These samples, with their lower water content, might be indicative of the aftermath of a massive impact event that formed the South Pole Aitken Basin. This event could have influenced the dichotomic distribution of water in the moon's mantle, with the far side bearing the brunt of the impact. From this, we learn that the moon is not a static, unchanging entity, but rather a dynamic body with a complex history that continues to evolve. This discovery leads us to our next insight. Coming in at number 8, the findings support the giant impact theory. The giant impact theory, or the Theia impact, is a widely accepted model that explains the moon's formation. It's a tale as old as 4.5 billion years, dating back to the early days of our solar system. This theory suggests that a Mars-sized body named Theia collided with the young Earth. The colossal impact was so powerful that it vaporized Theia and a significant part of Earth's outer layer. The vaporized material was then cast into Earth's orbit, forming a ring of molten rock and dust around our planet. Over time, this debris coalesced under the influence of gravity, eventually forming the moon. Incredible, isn't it? That our serene celestial companion might have such a violent birth. Now, the Chang'e 6 mission findings bolster this theory. The samples retrieved from the far side of the moon indicate a lower water content in the mantle compared to the near side. This suggests that the moon's formation involved high-temperature processes, such as those expected from a catastrophic collision. Moreover, the dichotomic distribution of water in the moon's mantle, which we will discuss in the next scene, could have been influenced by the massive impact event that formed the South Pole Aitken Basin, the largest and oldest impact basin on the moon. So, the giant impact theory, once just an idea, is now more tangible than ever thanks to the Chang'e 6 mission. With this theory in mind, let's move to our next insight. At number 7, the sample suggests a dichotomic distribution of water in the moon's mantle. Now, what does this mean? Well, it's quite simple. The term dichotomic refers to a division into two parts. So in this context, it means that the distribution of water in the moon's mantle is not uniform. It varies, showing two distinct patterns. This dichotomy could have been influenced by a massive impact event that formed the South Pole Aitken Basin, one of the largest known impact craters in our solar system. The force of this impact could have caused a shift in the mantle's composition, leading to this uneven distribution of water. It's an intriguing finding that not only deepens our understanding of the moon's geological history, but also leads us to ask more questions about how such events can shape the geology of celestial bodies. This water distribution pattern brings us to our next insight. At number 6, we delve into the massive impact event that formed the South Pole Aitken Basin. Imagine a colossal meteorite, hurtling through the vastness of space at breakneck speed, colliding with the moon. This cataclysmic event, occurring over 4 billion years ago, left an indelible mark that we know today as the South Pole Aitken Basin. This basin is not just any ordinary crater, it's the largest, oldest, and deepest impact basin on the moon, stretching over 2,500 kilometers in diameter and plunging 8 kilometers deep. That's roughly the distance from San Francisco to Chicago. This gigantic basin covers nearly a quarter of the moon's surface, extending from the lunar South Pole to Aitken, hence the name South Pole Aitken Basin. But what makes the South Pole Aitken Basin so fascinating is not merely its size. The cataclysmic impact that formed this basin was so intense that it penetrated the moon's crust and reached the mantle, bringing up subsurface material. This makes the basin a treasure trove of information, providing us with a unique window into the moon's internal structure and its geological past. Samples from the Chang'e 6 mission suggest that this massive impact event may have influenced the moon's geology significantly. The findings indicate a dichotomic distribution of water in the moon's mantle, potentially influenced by this very impact event. These revelations not only enhance our understanding of the moon, but also shed light on the early solar system and the violent processes that shaped it. This massive impact event that formed the South Pole Aitken Basin underscores the moon's dynamic history, a history marked by celestial collisions, geological transformations, and of course, water. As we continue to unravel the moon's secrets, each discovery brings us one step closer to understanding our place in the cosmos. This massive impact event leads us to our next insight. Halfway through at number 5, the Lunar Mantle's composition. The Chang'e 6 mission has shed new light on this mysterious layer of the moon. The mantle, lying beneath the lunar crust, has been a topic of intense curiosity for scientists. The samples collected by the Chang'e 6 mission provide a treasure trove of data, revealing a fascinating glimpse into the moon's geological past. The mantle's composition is key to understanding the moon's origins and its evolution over billions of years. The samples suggest a lower water content in the mantle on the far side of the moon, supporting the hypothesis of the moon's formation from the debris of a giant impact on Earth. This dichotomy in water distribution between the near and far side of the moon further fuels the intrigue surrounding the mantle's composition. These findings add a new chapter to our understanding of the moon's geological history, serving as a testament to the power of lunar exploration and the wealth of information waiting to be discovered. The lunar mantle's composition sets the stage for our next insight. At number 4, the unique characteristics of the moon's far side. Often referred to as the dark side, the far side of the moon is a treasure trove of untouched geological history. Unlike the near side, the far side is heavily cratered and has a thicker crust. It's a stark contrast, a silent testament to the moon's tumultuous past. The Chang'e 6 mission samples from this region reveal fascinating insights. They indicate a lower water content in the mantle compared to the near side, supporting the theory of the moon's dramatic birth from a giant Earth impact. The samples also suggest a dichotomic distribution of water, potentially influenced by the massive impact event that formed the South Pole Aitken Basin. These findings not only deepen our understanding of the moon's history, but also lay the groundwork for future lunar exploration. They remind us that every crater, every rock, every grain of lunar dust has a story to tell. The moon's far side brings us one step closer to our top insight. Coming in at number 3, the geopolitical implications of lunar exploration. The moon, as we know, is not just a celestial body in our night sky. It's a stage where geopolitical dramas play out, a frontier for nations to demonstrate their technological prowess, and a resource-rich environment that could potentially fuel future space exploration. China, in particular, has been making significant strides in its lunar ambitions. Their goals have evolved from symbolic gestures to a systematic push for permanent space infrastructure. By the year 2035, they plan to have a permanent international lunar research station. It's not just about the science, it's about leverage, influence, and coalition building. China is strategically leveraging lunar resources and technology for geopolitical influence, rallying a coalition of nations for lunar exploration. This strategy is seen by some as an attempt to rewrite the lunar geopolitical script, and it's drawing attention from across the globe. One nation keenly observing China's lunar exploration is the United States. For them, China's space program is a rallying cry for their own Artemis program. It's not just about national prestige, it's also about security. The competition, however, is not without its challenges. There are concerns about the U.S. structural weaknesses in long-term space competition compared to China's centralized coordination. This lunar rivalry has implications beyond the two superpowers. It extends to the Indo-Pacific region, with concerns about overlapping communication networks and territorial control in cislunar space. The moon's geopolitical landscape is complex, and the stakes are high. China's lunar ambitions and the ensuing geopolitical dynamics are reshaping our understanding of space as a frontier for national competition and cooperation. As nations jostle for influence and control over lunar resources, the moon is becoming more than just a celestial body. It's becoming a geopolitical chessboard. The geopolitical implications of lunar exploration lead us to our second top insight. Almost there at number 2, the future of lunar exploration. As we stand on the precipice of new lunar frontiers, we can't help but marvel at the ambitious plans that lie ahead. The moon, once a distant dream, is now becoming a tangible reality. The next big leap in lunar exploration comes from China, with their systematic push towards establishing a permanent international lunar research station. Slated for completion by 2035, this isn't just about planting a flag and leaving a footprint. It's about constructing a lasting infrastructure for continued scientific discovery, a testament to human ingenuity and persistence. But this isn't just a solo venture. China is building a coalition of nations for lunar exploration, fostering international cooperation in the shared pursuit of lunar knowledge. This glimpse into the future brings us to our top insight. And finally, at number 1, the moon as a resource. The celestial body we've admired from afar for millennia is not just a marvel to behold, but a treasure trove of potential resources. The moon's crust is rich in valuable minerals and elements like helium-3, an isotope that could potentially fuel clean fusion reactors here on Earth. This isn't the limit of the moon's resource potential. The lunar surface also holds abundant reserves of water ice, particularly near the poles. This could be used for life support in lunar bases or broken down into hydrogen and oxygen for rocket fuel, making the moon a potential pit stop for further space exploration. But it's not just material resources that make the moon so valuable. It's also a resource in terms of knowledge and technological advancement. Studying the moon gives us insights into the early solar system, the formation of planets, and even the history of our own Earth. Moreover, the technological advances achieved in the process of lunar exploration can have wide-ranging applications in various fields back on Earth. Leveraging lunar resources is also a strategic move in the geopolitical arena. Nations are vying for a foothold on the moon, not just for scientific exploration, but also for the prestige and influence that comes with being a spacefaring nation. Establishing a presence on the moon is seen as a stepping stone to Mars and beyond, paving the way for a new era of space exploration. But as we venture forth, it's crucial to remember that the moon is a shared heritage of all humanity. Its resources, while potentially vast, are not infinite. We must tread carefully, balancing our ambition with a sense of responsibility and stewardship. With these top 10 insights, we hope you've gained a deeper understanding of the moon and the exciting future of lunar exploration. So there you have it, folks, a comprehensive look at our celestial neighbor, the moon. It's not just a beautiful sight in our night sky, but a source of endless wonder, scientific discovery, and potential resources. We've journeyed through its mysteries, its potential, and its future. But the exploration doesn't stop here. We'd love to hear your thoughts on this incredible journey. What was your favorite part? Do you have any theories or insights of your own? Let's continue the conversation down in the comments below. If you enjoyed this video and want to be a part of our journey through knowledge, make sure to hit that like button. It helps us to reach more curious minds like yours. Don't forget to subscribe to FactFusion and hit the bell icon for updates on our latest videos. We delve into diverse topics, from the mysteries of the cosmos to the intricacies of our own planet. And remember, knowledge is a gift best shared. So feel free to share this video with your friends and family. Let's embark on this journey of discovery together. In the end, we're all explorers, and the universe is our playground. So, until next time, keep exploring, keep learning, and as always, thanks for being a part of the FactFusion family. Stay curious.